Okay, morning everyone. Thanks for taking the time today to join our Friday Forum. The topic today is fundamentals of LED walls for home cinemas and media rooms. So we'll see what we can cover in that expansive topic in this short session. Now, as always, I have some notes written down of where I want to take this sort of discussion today. However, if you use the chat box on the side of the screen, whilst we're doing these live recordings, you're absolutely welcome to ask questions, and I'll try and weave that into the discussion as we go along. Okay. So, um, Surround Group is starting to lean much more heavily into LED walls. I think that we've all seen for a number of years now that it could be the coming solution. I think that the time is finally here that it is a valid solution. It's not a solution that replaces projectors. It's not a solution that replaces TVs. It is a solution that, in the right project, can really enhance the sort of options that you've got. It's another palette of tools to be used to deliver great visual experiences to your clients and on your projects. Now, I guess the first question always in a session like this, is anyone already specifying LED walls on your projects? Um, Maybe it's a little bit too soon to see that yet. Aki says yes, good. Now, related to that though, who thinks in the next 2 years that they will have to be specifying LED walls on their projects? And I hope that everyone has put their hand up. Now, we have previously done a session on architectural uses of LED walls. That session wasn't recorded, so I'm going to go back and redo that one soon so that people can watch that back again. And that's why we wanted to speak about home cinema and media rooms. But just to touch on both of those, the thing that an LED wall gives you is a pretty unlimited canvas to present information, video, however you want to generate that. Um, and that's the main reason I think that taking a little bit of time while we all work out where am I going to use these things, but now the use cases are becoming much clearer. Art, architectural uses, as well as media uses. So you're all going to have to get to know how to do LED walls. And the good news is that Surround Group is here to help you with all of those things. We're lucky enough that we work with Layard and Barco. We have demonstration facilities in the UK and in Belgium. Lots of training. We can help you specify these things. We can help you plan the whole install. And we can even help you with the installation itself to make sure that everything goes as smoothly as possible so you don't need to worry about it. Now, I've said that deliberately because for me personally, I think the biggest um, barrier to LED walls, and obviously you guys are welcome to correct me, is a certain sense of, don't call it fear, nervousness, perhaps. They're still not inexpensive. They are, you know, fairly complex to put together if you've not done it before. Everyone's heard horror stories about, oh, it looked all like this and that when it was all finished. So basically, we have put you here to try and convince you that if you work with Surround Group, it's going to be a good experience as you go through these things. Okay. Now, um, let's just start off with some of the basics then. Um, for those who might not have seen an LED wall before. Just find- So first of all, what you've got to do is you've got to understand the components that are inside an LED wall. So here's a little graphic that I made up that helps us to understand. So just a reminder, if you click on the screen, you'll get a full screen view of these things. Excuse me. So regardless of who you're working with, there are several sort of pretty common components that fit together to make up an LED wall system. The first thing that you have is the LED module. So the module is the thing that has the physical LEDs connected to it. A module can be a front axis or a rear axis. That just describes how it fixes into the LED cabinet. Um, you'll actually find if you look at a module, there's quite a lot of electronics on the back of them, and usually that's to control how the LEDs themselves are driven. Now, the module is on the front of the LED cabinet. Now, what else is inside the cabinet? Well, obviously you have a power supply, and then you have this thing, the receiver card. The receiver card is what gets the data that's being sent into the LED wall, and transfers that onto the module basically to get replayed. Um, pretty much every LED has these components. Okay, there's lots of different ways that they can get simplified or integrated, but when you look at it, you've got these basic components. Modules go into cabinets. Cabinets lock together to make your overall wall. That's how it all works. Now, what goes around that whole stuff here? Well, what you have is the controller and the sender. So that is the thing that connects your sources with your LED wall. So remember, your module, your receiving card, your power supply are all inside your cabinet. And what happens is that the controller, it's probably got, in our case, because we're talking about home cinemas here, HDMI. It might have a display port, which can be quite useful. All of those type of connectors. It processes those. It decides which receiving cards it's transmitting what data to, and it sends that out. That's typically done over a copper Ethernet cable. Not normally a fiber cable, normally a copper Ethernet cable. This right here. Now inside the LED wall itself, you have a number of connections. That might be an Ethernet cable. It might be a proprietary ribbon cable, a cable basically that connects the receiver card with the modules, and then they output the information. Now, one of the things that will sort of catch you out first time you put these things together is that you receive a big pile of boxes. Let me just take it off share just now. You receive a big pile of boxes of LED cabinets with modules inside, probably receiving cards. And you're like, well, what do I do with this? Is there like a specific way that these things need to, click together? What happens if I get it wrong? Well, one of the main jobs of the controller unit that we just looked at is to address the right signal to the right uh, cabinet. So what you'll do in the setup is you will create a map, basically. So you'll plug all these things together up on the wall. You'll build up your big wall, and then you'll have your cables going from the receiver card back up to the sender. Now, pretty likely is that when you switch it on, it does look all over the place. My face will be split up over 4 different screens or whatever else. Um, that's because it's not been addressed. So just think about it. If you have like 10 TVs and you just randomly plug in the TVs, you'll get a picture on all of them, but it might not be correct. The good news is that in the controller, the next step of the setup almost always is that you go in and you fix the mapping. So basically, it knows what port is connected to what display and how that should correct up what cabinet, sorry, so that it knows how to present the display properly. And normally, what will happen is you have a display on the screen, you will highlight that, and a section, one of the cabinets will light up to show, hey, you're talking to me, and then you can correct how the map is done. Um, if anyone has ever done addressable pixel LED, it's a fairly similar concept to doing all of those types of things. So it's not something that you need to panic too much about. It's just a process of going through and getting everything set up. Okay. Do we got any questions about those components, receiver cards, senders, all that type of stuff? Everyone's happy with that. Perfect. Now, um, the next thing when we're looking at LED walls is you get different types of LED walls. So the most common types that you will see are SMD, which stands for Surface Mount Device. So an SMD wall is probably what you think about most when you think of an LED wall. So an SMD wall literally is little surface mounted LEDs, just the same as you would get on, anything else that has little surface mounted LEDs. There's just a hell of a lot of them on the board. There's nothing more amazing than seeing a guy resoldering those LEDs um, on the module whilst it's still on the wall. Let me tell you, that takes a steady hand. Um, Surface mount device uh, has a big benefit. It has an excellent uniformity across its surface. They all just look the same right across the whole surface. I'm pretty sure you can imagine, though, the big downside of an SMD wall is that they can be a little bit fragile. That's not to say that they, detonate and fall apart or anything like that, but um, I can say from experience, even when installing an LED wall with SMD LEDs, it's very easy just to catch an LED, and there's nothing more painful than seeing that one microscopically small LED ping off into the distance, knowing that you now have a dead pixel in the middle of a brand new LED wall. It's all fixable, right? It's just annoying. For that reason, though, we don't start with SMD as the first choice for residential. What that does is it takes us to the next type of LED, which would be a COB LED. So COB stands for chip on board. Now, a COB LED has got lots of technical things about it that make it chip on board, and all of those are outside the scope of today's discussion. The cool thing about COB is that COB has an epoxy type layer over the top of the LEDs. So it is unbelievably robust. It's so robust, in fact, that you can normally on almost all COB displays take a damp cloth and give them a clean. Someone slaps a big hand right onto the display, jam fingers all over it. I mean, we'd hope that doesn't happen, but in a residential, who knows? They can be cleaned quite easily. If someone leans against it by accident, that's not going to cause it to instantly, lose lots of LEDs or anything like that. The downside of COB is the uniformity. Because the way these modules are made, there's like a limit to how big they can be done. And actually, when you see it without something playing, the way that the light refracts through the epoxy layer can make them look, yeah, checkered a little bit. You've probably seen that at shows if you've walked around or anything. It doesn't show up in the normal content that's playing, but it is something that just you don't get everything for free, do you? That's the Achilles heel of some co-op displays, but they're very, very robust, so that's why we like them. There's a third type which is gob, glue on board. Gob's similar to cob. You'll typically find them outdoor. We're not going to talk about outdoor today, but just to let you know that we do have those solutions also available, and they are gob solutions. So those are the three types of things that you'll hear. So the rest of today, we're mainly going to be looking at cob with a teeny bit of SMD thrown into that. Now, any questions on display types, finishes, or anything like that before we move on? Probably not. Straightforward stuff. Um, Now we come to the sort of the next thing that we've got to look at for our home cinema applications, and that's planning. How do we plan for the installation? How do we pick the right product for a project? Now, um, even for me, we're still learning a bit on these types of things. Um, and it actually helped me a lot. We were at a lighting show this week, and it really helped me a lot to remind myself about how LEDs work, because an LED wall and an LED light, unsurprisingly, have a very, very great deal in common with each other, because they're both LEDs. Um, Now, the first thing that you've got to think of when you're planning your installation is perhaps not immediately obvious. You've got to think, how bright is the room going to be? Um, so if you're doing like a media room, maybe you're looking at an LED wall for a beautiful media room with a huge glass wall, south facing, sun's going to be coming through it all day long. I'm sure you know one of the advantages of LED is that you can specify them with huge light outputs, 600 nits, 1,000 nits, 2,000 nits, even some of them. Now, that lets you overcome the light that's falling on them. But just like in lighting, there's a trade-off that you have to be aware of. So I spent this week talking to people about how our lighting products have 16-bit addressing, and how that addressing allows us to achieve very low fades and smooth movement out of black. Well, that of course also applies to LED walls. So when you look at the LED wall, and the processing and the receiver cards and all of that type of stuff that you pick, one of the most clear things that separates, like, I don't say an entry level, like a more basic LED solution from a very, very high-end LED solution is the number of bits of data that it's using to determine the grayscale. Now, that also comes into play um, when you look at how bright your display is going to be. I'll use an extreme example. I'll use outdoor displays for a second. So you can get those suckers that are like 5,000 nits, big commercial signage display, 5,000 nits, so that when the sun's shining full on it, you can still see it and read it. But those will typically be 10 bits, 12 bits of grayscale. So those 10 bits limit the change basically each step can be. The less gradation that you've got, the less detail you can get in dark areas of the image. So actually one of the most important points with the LED wall is kind of trying to match the brightness requirement with the application. Now, where that obviously really comes into play is if you're doing a home cinema and you want to put an LED wall in there, it's very easy to fall into the trap where you go, we can do lots of brightness, let's put 1000 nit LED wall in there. But then you make a mistake and you put like a 12-bit processor on it. You will have quite poor, don't maybe that's the wrong word, a suboptimal, low black experience. So I'm sure everyone remembers, well, hopefully, Game of Thrones in the final season and the whole episode that no one could see on their TVs because it was all so dark. That's not the display that you want to be watching that Game of Thrones episode on. Whereas, for example, the DCI LED wall, the Infinity wall that we offer, um, it tops out at 300 nits, and 300 nits is the DCI HDR standard. And you go, 300 nits? That doesn't seem that bright. What's wrong with it? It's actually because that 16-bit display has been optimized to have unbelievable low grayscale performance to deliver for a home cinema application as opposed to a media room application. So that's something that it's very, very easy to overlook in your planning. Um, the brighter the display, the more bits you have, the better. And if you can really match lots of bits with the optimal light output, that's how you get the best overall result that's possible to get. Okay. So that's the first step then is planning. Now, I mentioned SMD and COB. An Infinity wall, which is the DCI certified, uses SMD LEDs because it needs to have perfect uniformity, absolutely perfect. So it uses those SMD LEDs. It's the only product that we offer that uses those SMD LEDs, but we assume that someone doing a system at that level, because I'm telling you, the thing is just unbelievable. It's up there price wise. Probably can afford to look after it a little bit, which will be totally different in a family media room where the robustness obviously is going to be a key consideration in the whole choice. Um, the other thing that you want to try and decide is how are you going to like finish the display? Are you just going to mount it straight onto the wall, TV style? So that they're not very deep. They'll project out of the wall about that far. Are you going to try and build it in? Look at, super flush, beautiful looking. So really one of the things with LEDs that always amazes me, um, I've been designing downlights recently, and it amazes me even more in that particular application, is how much heat is generated by LEDs. Okay. If you put 8 million LEDs into a small surface, which is, remember what we're talking about, the technology is no different than a light bulb. It's 8 million light bulbs on the screen. It does get warm. Cob is much more efficient because of the way that it all works. but don't ignore that fact. Now, almost all LED walls will use convection cooling. Basically, the heat rises. So if you're going to flush it in, you've just got to be aware not to prevent convection from happening. Um, Ideal, maybe a little bit of extract to stop the heat building up in the room. So that's your other thing that you've got to decide when you're building them in. Balance the aesthetic and the technical. Obviously, we are here to help you with all of those things. Now, the final thing is, I am sure everyone has heard the horror stories and has walked around trade shows and gone, "Oh, I can see the lines on that LED wall." The reason that you see those lines is the cabinets, they spend huge amount of energy and investment to machine these cabinets to very, very high tolerances so that when they screw together, they don't move relative to each other. But all of that does come down to mechanical process. You've got to screw them together. They've got to clamp up. The the issue, if you've ever tightened up a screw, is that a screw can come loose, and if you get vibration or anything like that, you start to get a bit of movement. Maybe they move, you know, the wall might settle, whatever else it is. One of the biggest challenges that you'll actually get with the LED is if you put that into the cinema, and I'm sure everyone's doing 422 infra subs in every project these days. If you're doing less than 20 subs, you're nobody, it seems. Um, the vibration, remember, of that base makes the wall move. That's the whole point, most cases, of the sound isolation system that you develop. Well, that couples pretty much into your big LED wall, which is made up of 12, 16 individual modules all moving separately to each other. That is a recipe for every 6 months having to go and just adjust the alignment of everything. Um, if you can consider your mounting wall, your baffle wall, if you want to call it that. If you've done the cinemas, you'll be familiar with baffle walls. The same sort of a concept applied to an LED wall will make your life 100 times easier. Isolate it from the rest of the structure so that the base energy doesn't travel into it. Make sure it's very flat. Make sure it's very easy to put fixings into and level everything out. Build a little bit of cooling into there. Think about how your speakers are going to mount, what's your fabric finishes, or anything else going to be around the display. Now, naturally, we have a solution available for that called the screen wall, but that's something that you should not underestimate. If you just take an LED wall, and they come with the brackets and all that type of stuff in the main to fix to a flat wall, that's fine in sort of normal conditions. But if we're talking about media rooms and cinemas where there's bass and all of that type of stuff, it's probably a recipe that you'll get some movement if you ignore the reality that you're going to have to think about the wall just a little bit more and make sure it's nice and flat and secured. And in particular, isolation. Okay. Now, we've had a couple of comments here as well. Let me just touch on isolation just for a second. Isolation of sound is a really critical point in all of the cinemas that we do, and surely I will do one of these Friday forums on that exact subject. But what's been really interesting to me lately is that probably the last 6 months, almost every cinema that we have seen has had a specific requirement for the speakers to be isolated properly from the structure. Now, that was always the right way to do it, but people didn't do it. But now, when there's an acoustic consultant or anything like that, they're really, really, really calling out that isolation. Now, the reason to do that is that vibration of the speaker couples to the structure. And structural noise is one of the most difficult, if not the most difficult, to contain within the cinema. So if you isolate the speaker, you can prevent a lot of noise issues. But it also, in the context of our LED wall, stops the thing shaking. Yeah, all isolation brackets and all that type of stuff. It truly is another subject, but of course, we have been working very hard on all of those types of things. Just to give you some idea, a fairly straightforward passive speaker isolator, as long as you put enough load onto it, um, will probably be 95% efficient down to maybe 70 hertz. So for cinemas, you can cut out almost all of that vibration from the main channels. It gets a little bit more complex for the subs. The flip side, the subs are so heavy that you can get their natural frequency of isolation down a lot more. So just don't ignore that whole subject. Um, okay, the big one, the big one when you are specifying your LED wall, pixel pitch. Is everyone familiar with the term pixel pitch? It's like the number one thing that everyone gets concerned about is to have the lowest possible pixel pitch. So what the pixel pitch describes is uh, the spacing, the center to center spacing of the individual LEDs. Now, the systems that we are involved with go from 0.7 millimeter to typically 1.2 millimeter. You know, everyone goes, oh, 1.5, that sounds terrible, don't want it. So it doesn't happen. 0.7 to 1.2. A 0.7 millimeter, you know, if you have a ruler or something like that, go and look and see how much a millimeter is, and then shrink it. That is tiny. It's absolutely minuscule. But people still get hung up very much on the pixel pitch. Now, I tried to flip that around, okay? So who in here has done projection systems? Everybody, right? How many times have you sat thinking in your projection system, really worried about my pixel pitch of my image? Okay. Now, because I also own a projector screen company, let's not forget, um, I have some idea on the sort of average sizes that people put into cinemas. And actually, around 4 meters is the pretty typical size that we sell. Well, guess what? 4 meter projector screen with a 4K projector produces a 1 millimeter pixel pitch. Okay. Um, cannot remember the last time someone phoned me up to say, "Oh my goodness, I can see the pixels in the cinema on my projector." Now, of course, that's a bit facetious. It's not exactly the same thing, but I want you to understand that it's not something to be really terrified of. Um, Fixed pixel devices have been fixed pixel devices for a long, long, long time now. So we've had to deal with these things for a long, long time now. The difference that you might get with an LED is that it doesn't have a 100% fill factor, but nor does a DLP chip, but it does have a certain softness and things like that compared to the very hard edges of obviously a physical LED. Now, um, when you don't tell people the pixel pitch and you just ask them to look at something, you can have wonderful fun and be a horrible prankster when you're doing demonstrations and stuff like that. Hilariously, you will often find that people prefer a 1.2 millimeter over a 0.9 millimeter. The reason often is that you just get a little bit more fill factor, and if you're at the right distance, you don't say one's bad and one's good. You go, and it looks, I don't know, better. Hopefully, that's the right answer. And you've been obviously tricking me in this demonstration that we're doing. Um, it's not something to get too hung up on. Don't ignore it. So we have a very simple rule that we use when we're specifying these things with our partners. Take the pixel pitch and multiply that by 2000 to get the approximate distance where you simply cannot see the difference between the pixels. So that 1.2 mil that I just spoke about, if I multiply that by 2000, where am I at with that? I'm going to be 2.4 meters ish. If my terrible fuddled brain is even approximately right. If you do zero point 0.9 times 2000, that's 1.8 meters. You know, these are not big distances in cinema terms. If you're putting your front row 1.8 meters from the screen, there's probably another discussion that needs to be had about the design. So yeah, your viewing distance, we got the question there. Is viewing distance a key part of specifying? Yes, 100%. So let's take an extreme example. If you are a commercial cinema, um, like an Odeon style, Cineworld, all of those types of guys, um, and you're going to put in a 20-meter LED wall, what resolution do you think that 20-meter LED wall is going to be? It's going to be 4K. Okay, that means you're going to be using like a 5 mil pixel pitch, but no one goes, "Oh, how crap!" They're not going to put a 16K LED wall into the cinema because the viewing distance is going to be appropriate to the size of the screen. It's just that simple. Um, we'll come on to another bit, though the pixel pitch is still not to be ignored, but we'll come on to another little bit of that. Just, we see it always that people get really hung up on that. Now, I'm sure that you can imagine the smaller the pixel pitch, the higher the cost becomes. Um, it is important to just not overhung on the thing and do the wrong spec if you're looking to get that right for your projects. It's going to be the right viewing distance. 0.9 works great. 0.7, if you have the client that says, I want the best, of course, we'll offer them the 0.7. You'll just have more resolution and all of that type of stuff in the same area. And if it's a small room, of course, that also plays a part in the whole thing. But just remember that. And remember, your 4-meter projector screen already has a 1-meter pixel pitch. You know, your 3-meter screen that everyone does, 120-inch screen, it's about a 0.7. Okay, it's not any different to those types of things. Now, my note here says I want to talk about aspect ratios next. But aspect ratios also touches on pixel pitch. So if we think back to the start of what we were talking about, let me just quickly share the screen again. So what we spoke about here is the LED module inside the LED cabinet. Now, those LED modules are going to be smaller than the cabinet. You'll typically find 4 or 6 LED modules per LED cabinet. Now, the overall screen that you're going to create is made by bolting together a number of rows and a number of columns of LED cabinets. Those LED cabinets are going to have a fixed number of LED modules, rows and columns inside them as well. So what that means is that unlike a projector where you can zoom in and out, you have hard cabinet-sized jumps in the resolution and in the aspect ratio that you can deliver on a project. And one of the things that it's kind of changing, but still appears in a few things is for manufacturing efficiency reasons, they might not always make the LED cabinet a 16:9 aspect ratio. What that means then is that when you're bolting these things together, you can't always deliver multiples of 16:9, which is what we are obviously used to when it comes to home cinema and media rooms. So let me just stop sharing just for a second. So what does that mean for the whole thing? So um, there's a question here about costs. And just because we're recording this, I won't talk about costs and everything. Obviously, those change over time, and we can discuss that after we've stopped the recording. We offer a range of solutions. Um, our least expensive solution is about a fifth the price of our most premium solution. So it's quite a big span over that. If we do a 4K model of the least expensive solution, the cabinet aspects all give us a 16:9 ratio. But if I try to do slightly smaller or change the sizes, it doesn't quite work out. So we quite often end up with say a 2.2 aspect ratio instead of a 2.37 aspect ratio when we're doing that. Now, also related to that is if you want to take a very high resolution, a 0.7, the screen is going to be smaller given resolution compared to if you're using a bigger pixel. Just the pixel uses more space, therefore the screen is bigger. So one of the things that can be messed up is that a really smaller screen can be way less, more expensive than a much bigger screen if they have the same resolution. So you have to think a little bit different. When you're doing a projector, you throw it up, you do your zoom, and it just is the size. LED's not like that. It's like a fixed thing that you're working with. Um, what's super cool though is we have all of this amazing tech now. The processing that comes with the LED or amazing video processors like a Mad VR that will just fit any content to any aspect. When you start to look at LED walls, one of the coolest things is that you can escape, I'm going to say, from 16:9. If you want to do a whole wall, as long as we can kind of make it fit, yeah, why not? Why not do a whole wall? Then we'll make the image fit in like a central area so that it's not too big or too small. And maybe the background can be nature videos or wallpaper or whatever it is that someone wants to have. You can be way more creative with those whole things. But you might not always be able to deliver an external 16:9 or 2.35 or whatever else aspect ratio. So, as has just been put in, it's absolutely planning. It's planning, but it's also educating the client on the project. Because what you are able to do with LED is present them with a solution that can be used for a lot more stuff. We're not going to talk about architectural, that's a different presentation. But the architectural applications of LED walls, if you've got a dark basement, you can do an LED wall right along one wall that simulates a window. We can transport ourselves off to the Caribbean or into the desert or down to the beach or whatever else it is that we want to do. Um, you just can't really do that with a projector, but you can with LED. And then you can use picture in picture and do all types of interesting stuff. You want to do sports and have, American style 15 games on the screen at the same time. Sure, no problem. We'll do that for you. So lots and lots and lots of different opportunities that come. Um, so don't get hung up on the aspect ratio or the pixel pitch, because when you do that, that's when you get yourself really start to sell yourself out of what would be an amazing solution on the project. Okay. Now those are quite complex uh, subjects that we just covered there, and I know I'm just explaining these things to you. So hopefully everyone was able to follow along. Is there any questions on the pixel pitch and the aspect ratio and how we can lay these things out before we move on? Nope. Okay, perfect. I'm aware of the time as well. Okay, so we got a question about cost, and happily that's the next thing that I want to talk about. Not numbers, but what separates. Okay. So I've mentioned that we have, uh, I don't want to call it an entry level. Of course, it's still a premium solution, an accessible solution for anyone that's done, high end projectors before. LED is now at that sort of price point for a very good system with a warranty, with spares, all the rest of the stuff. Now, what separates a system like that with one that's 10 times the price? Okay. How is it possible that there can be such a disparity over one that's good, but one that's just so much more premium? Well, the first thing is that LEDs themselves obviously have an impact on that. Just as in lighting, you can buy a super cheap LED that, you know, it's not very accurately binned or anything like that. The light comes out and it's fine across the whole display. With respect, if you're looking at many of the many OEM manufacturers in China, that's the risk that you're taking, is that you just have loose spinning kind of trash basically. The LEDs are different colors and stuff like that. They're not quite equal brightness. And of course you can do digital things to correct that, but it's no replacement for just doing it properly in the first place. That costs money. Um, but then you get the second thing. Um, so in lighting, if you do RGB or RGBW lighting, one of the most important things that you have to be concerned with is mixing. How do you get the mix to be as good as possible? Now, if you start to do linears or anything like that, what you have to try and do is actually alter the point sources of the light. So, as in, if you can mix up the red, green, blue, and white segments, you can get a much better mix result that's visible. So, remember, that's what we're looking for. In a TV, any fixed pixel display, basically, and especially in LED walls, the colors that you see are a mix of red, green, and blue. So anything that you can do to enhance the way that they mix has a massive impact. So Laird have just released a new model called the Komodo as our new premium model. Believe it or not, on the Komodo, point 0.7 with its 8 million pixels on it, those LEDs are selected and placed that they are mixed as it moves across the surface of the display. Um, it still kind of blows my mind because, of course, you can't just put the LED on upside down. The display has to know which channel's red and which channel's blue and all of that type of stuff. Otherwise, it would all be completely wrong. So, really, an unbelievable manufacturing process to deliver the very best color mixing performance. So that's just in the LEDs and in the manufacturing. The second part of that is in the dimming. I spoke about the number of bits that you get. More bits means more data. More data means that your transmission is higher. You've got to have more powerful processing to handle all of that. The receiver cards need to be more powerful, etc., etc., etc. More computing power means more cost. Just the trade-off that you have to make. And then the final thing, of course, is the quality of the processing that you put together. I kind of downplayed the receiver card, but a receiver card is doing an unbelievable job of managing all of these things that come out of the display. The processor is doing all of these things that come out of the display. So those are the elements that impact the cost of your LED wall that you're going to put in. Okay. Now, I realize that we have reached the end of our allotted time. If people don't want to rush off, I can continue at this minute in time. I'm still going to talk about a little bit of audio and then we'll do a Q&A, if that's okay with everyone. If you do have to go, I understand, and thank you for your time today. Now, the next thing that we want to talk about is audio. Okay. Um, what's the challenge of an LED wall? It's a big solid metal thing, right? You're not going to be putting a speaker behind that. Um, um, the in commercial cinema, there are a number of companies that are starting to look at doing acoustically transparent LED walls. Kind of the same principle as what a perforated screen works on. But remember what I said, if you've got 20 meters wide, you can afford to put holes in it. That's fine. If you're talking a 0.7 millimeter or a 0.9 millimeter pitch, we're not going to be putting holes in that thing anytime soon. So the idea of an LED wall residentially that's acoustically transparent, to be honest, is still, let's not say fantasy, but a technical challenge that we've yet to solve. So people have come up with several different ways to handle the audio in these spaces. So the first way that you might have seen is to put a speaker above the screen. That's Dolby's recommended way, just so that you know that in a commercial theatre and you're doing Atmos, Dolby require a speaker above for the center channel and then left and right of the screen for the left and right channels. For me personally, all above also works extremely well. You know, big sound bar style also works extremely well. Um, then I'm sure what you've seen is above and below. Now, the problem of above and below is how do you pan the voice basically to make it sound like it's coming out of the middle of the screen? That's actually quite a complex solution. Um, how do you blend those two things together? How do you overcome comb filtering and all of those types of challenges? Right, it's not an easy thing to do. If it's done right, it works great, and I'll show you what done right might look like just in a second. The third way that you probably have seen is to use speakers way back in the room, fire them off the screen, and reflect that sound back in. I never heard that sound anything other than trash, I'm sorry to say. The reason for that is, um, think how narrow your dispersion has to be from those side channels that the sound can hit the screen in such a small area that when it's reflected back, it it doesn't just sound like a big spread out mess. Um, Also, because of the way that sound decays with distance, it's almost impossible that you can have a speaker either side that's playing loud enough to have the level of a center channel when it's reflected back at you without those becoming obtrusive in the sound field. Apologies to people who are offering those solutions. There are several on the marketplace. I'm probably being insulting to them, but for me personally, I have never enjoyed listening to one of those systems. So I am an above screen or above and below screen believer for these types of solutions. Now, um, for those of you who follow Surround Group closely, you will know that one of our biggest things is the whole discussion of spatial audio. And spatial audio is a different thing to immersive audio. No doubt that's the sort of thing that you can get a punch up in a bar about the differences between those two systems. We define spatial audio as being separated from the content playback. There is a processing engine that takes the known speaker locations, processes that, and makes the objects appear in real time to come from the optimal place. Immersive audio, particularly in a residential context, is a channel-based solution. The decoder assumes where the speaker is, and it wants the sound to come from those assumed positions. It's not processed based on data. Now, what we do is we try to combine those two things. So let me share something with you, and let's hope that this makes sense for everybody. So here is the setup of a spatial audio system that's playing back Atmos 7.1 immersive content. Now, this is actually our own media room at our factory. The room is not very big, 4.2 by 2.7 meters wide by 2.4 meters tall. But we have 32 channels. There's 28 channels and 4 subs in that space doing spatial processing. Now, what you can see on your screen is our speakers. So those things there are speakers, back, middle, right, for example. And what you can see is that there's an exact X, Y, Z position of that speaker. Our system knows exactly where all of the speakers are in three-dimensional space. Now, what these weird looking sort of blue diamonds is, oops, these are objects, okay? So if I click on that object there, that's my side right speaker. What is actually happening in the real world is that there's an AES67 stream. So for our audio over IP fans, we take an AES67 stream in real time into our spatial environment. The system then analyzes where that should be and then plays that back using our physical speaker array. Now, what does that allow me to do? Right, let's say that surround speaker, I wanted to make that sound as though it was further away. I can move that out like that. I can make that sound as though it's way, way outside of my room. The processing software will actually do all of its computations to make it sound as though it's much further away than it actually is. So I can set up an optimal 714 based exactly on the Dolby spec for that room and let the spatial system use my physical speakers and its clever processing to play that back. Now, to bring that back to the LED walls, let me undo that. Here is the front of the room. Here is my speaker below the screen. Here is my speaker above the screen. Here is my sound object placed right in the middle of the screen. And what I can do is I can start to play with things like the size of that sound. Do I want that to sound big? Do I want it to sound wide? Do I want it to sound like it's in the middle? Do I want it to be slightly off to the side? Um, that's how we can do our spatial processing to really optimize the sound experience in these much more complicated spaces. Let me stop that sharing. So just to say that system, today we're talking about LED walls, obviously. Our little room has an 85-inch TV. It feels like an LED wall because our room is very small, and that TV is the biggest TV that we could physically fit on the wall. So the problems that we're trying to overcome are just the same. How do we get the best possible sound and front soundstage and all the rest of the stuff, knowing that we've put a solid thing on the front wall? So we've spent a lot of time looking at those solutions for you guys as well, as part of getting an optimal home cinema solution with large format fixed displays. So I've managed to run over by 10 full minutes. So thank you everyone for your time in this session. What I'll do is I'll just stop the recording now and then we can move to a Q&A. Okay. Thank you very much, everyone.